trigonometry, trigonometry. Trigon, that means three-sided shape. We're measuring triangles. Trigonometry, which is a very extensive unit in pre-calculus, but also its own separate course, is really the study of measuring triangles. But it's not just about triangles. We work with functions that are based on the angle measures that are inside of a triangle. And we're also working with circles because the trigonometric functions like sine, cosine, and tangent are really called circular functions. And it's what allows us to have periodic behavior that could be repeated and modeled using the concepts in trigonometry. So this is the first video in a sequence of videos related to trigonometry. And one of the first things I'd like to do in this video is take a look at a circle. The first thing that we can notice about a circle is the fact that if we start at one point on the circle and we move along the circle, we will have come to the same point that we started with. And the Greeks concluded that because there are approximately 360 days in the year, and that is a circular, periodic sort of behavior, we're going to let a circle have 360 degrees. I'm going to jot that down, 360 degrees. At the same time, though, it was discovered that the circumference of a circle, which we just really experienced by going around the circle, and that's the direction we'll go, by the way, which is we're starting in a standard position and going counterclockwise. The circumference of a circle is defined by 2 pi r. Now, something completely separate than that is the fact that the area of a circle is pi r squared. We're not really going to use that. I mentioned that so that we could keep these two formulas separate, 2 pi r and pi r squared. Now check this. If we were to take these two pieces and set them equal to each other, when we walk around a circle, we walked 360 degrees, but we also walked 2 pi r, inches or feet or meters. So let's set those equal to each other. 2 pi r, well, let me do 360 equals 2 pi r, so it's consistent. And I'm going to solve for pi in this particular case. So pi is equal to 180 degrees over a radius. Now that might not seem very special at this point, but what if we set the radius to be 1 unit? Just 1 unit of measurement. 1 inch, 1 foot, 1 meter, 1 widget. That means that pi would be equal to 180 degrees. You'll come to notice that this is super powerful. And in this moment, if we were to just let our brain start to accept the fact that pi is equal to 180 degrees, we could start to see the relationship and how that could form later on. So let's take that walk again. We're going to start at 0 degrees, and we're going to go 180, 360. Now let's do it again. 1 pi, 2 pi. So we went 2 pi radiuses, or radii, all the way around the circle. So let's put that on the shelf for now, and let's go back to that circle. Very simple. The Earth, again. Now, I want to share with you how we could sketch a three-dimensional circle, otherwise a sphere. Let's start somewhere around halfway on the circle, and we are going to draw a curved line down and come back up. And so that's what we would see as the front of the Earth. And now let's do a dotted or dashed curve on the back of the circle. By making it dashed, it's sort of communicating that it can't be seen. And now I'm going to do another piece here, and it's going to be a vertical feel to it. And so I'm going to go a solid right and back, and then a dotted on the back side. So we're getting very practical here, and to get super practical, let's call this the equator. And if that's the equator, then the orange line or curve would be the prime meridian. So the prime meridian is the line of longitude that goes through Greenwich, England, which is Greenwich Standard Time, GST, that you would see on a computer when you set your time. And the equator goes through some of the Caribbean islands where it's nice and beautiful and great places to go on vacation. So I am currently in Central Texas, and I pulled out my phone and I wanted to find out my GPS coordinates. And when I do that, I use the compass app, and the compass app tells me that I am approximately 30 degrees. So if this is the center of the Earth, I'm approximately 30 degrees north of the equator, which is pretty difficult to understand in terms of this picture. So I'm just going to try to estimate it here. The North Pole is right up at the peak. The equator is right over here. So 30 degrees would be kind of touching the Earth over here. So I'm not in the center of the Earth, but I'm creating a 30-degree angle with the center of the Earth. Okay? And going straight north would be 90 degrees. So that's interesting, about a third of the way towards the North Pole, north of the equator. Now, my handy-dandy compass on my phone also tells me that I'm 97 degrees west of the prime meridian. That means I'm more than 1/4 of the way around the Earth compared to Greenwich, England. So I'm not going to sketch that on this visual right now because we're just going to focus on that latitude measurement. So let's take a peek at that. If you have your calculator handy, I'm about to show you the steps how to convert between degrees and DMS. In other words, degree and decimal to DMS, which literally means degree, minutes, seconds. Degrees, minutes, seconds. So there are 60 minutes in a degree, just like there are 60 minutes in an hour, and there are 60 seconds in a minute, which means there are 3,600 seconds in 1 degree. So if 1 degree wasn't small enough for you to actually create an angle, we're allowed these minutes and seconds to get more precise. And that's exactly what that compass does for our GPS coordinates. So let's take this latitude measurement and let's convert it to a decimal value. So what we're going to do, it's a little bit tricky at first because the degree symbol on the TI-84 calculator is kind of really deep into the catalog for the calculator. But in general, what we're going to do is we're going to enter these values in the calculator, and we're going to do it 30 degrees, and then we're going to go through this cycle. So the first thing we want to do is enter 30 degrees. So to do the degree measurement, so this is just on the main screen, we're going to press second zero for the catalog. And instead of going down, what we want to do is go up. Okay, so press, you're going to type in 30, press second 0 on the which is the catalog, and go up. So arrow up, and so this first symbol is the degree measurement, and then this is the minute, and this is the seconds. So the degree symbol is quite far up. It's actually very, very close to the Z in the catalog. So you're going to go up, 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 and hold it down until you start to see that. Now there's a little square hole or square degree looking symbol. That's not the actual one. Okay. And after we do all of that, which seems kind of long, it's not very long after you get the hang of it, then we're going to press enter after the very last symbol. And what you would get for this particular degree measurement is you would get 30.557. So if you have a calculator to test that on, you could go ahead and try that, pause the video, and enter that and see if you can verify that measurement. The nice thing about this actual value, so this is in degrees by the way, the nice thing about this is because 33 minutes is slightly more than half of the amount of minutes in a degree, which is 30, then you're going to get a decimal value that's slightly more than half, so 30.5 something. So that's actually quite logical. So now what we're going to do is we're going to go the other way around. We're going to wrap up this video with that. We're going to go DMS to decimal. So, sorry, decimal to DMS. Oh no, shoot. Looking at my sheet here, it was wrong on my sheet. So decimal to DMS, that's correct. Okay, so we have a decimal degree, so decimal degree, and we're going to convert it to degrees, minutes, and seconds. Now this on the calculator is actually a little bit quicker because we're literally just going to type in this value and then we're going to convert it using one function on our calculator. So what you could do is you could leave this answer on your main screen on the calculator, and then you're going to go through these steps here. So step 1 is you would press second 0 again for the catalog. Step 2, what we're doing is we're going to look for this little sideways arrow with a DMS next to it. So what we're going to do is, to get there quickly, now you could just scroll from A down to D, but to get there quickly, since you're already on alpha mode, what you can do is just press the letter D, which is on the left side of your keypad, X to the -1. And you're going to scroll down and look for DMS. We're going to press Enter on DMS, and then we're going to press Enter again to actually evaluate that 30.557. Now we didn't need the actual degree measure, that degree symbol inside there, to show the calculator that we're in decimal degrees. It's assuming that we are. All right, so once you do that, if you did it completely accurate, meaning you left that previous value in there, you would get 30 degrees, 33 minutes, and 29 seconds. Now, if you typed in 30.557, you would have gotten something slightly different because it's rounded. 30 degrees, 33 minutes, and 26 seconds. So it's slightly different than the value down below here. So that is all I wanted to mention in this particular video, just dealing with degree measurements. So what you could do as a follow-up is you could attempt some exercises that have you convert between decimal and DMS, or degrees in decimal and DMS and vice versa. Alrighty then, thanks a bunch for watching.